Hello, good morning all. This is Dr. Abdul Pasha. Today I am going to give presentation on unit commitment. So what is unit commitment in power system operation and control? That we are going to discuss for today's lecture. This is lecture number 5. So what is unit commitment? So unit commitment is a process in power systems that determines the best schedule for all the generating units in a power system network. So here the goal is to minimize the operational costs. To reduce the operational costs, we are using unit commitment problem while meeting the load demand and other constraints. So unit commitment involves in deciding the generating units to start and stop at each power station. It also involves in determining the levels of production from each generator case. So the process is very important because it helps in avoiding constantly running generators. So we know that power system has grown very large in size and complexity case. So in that, the total generation on the system will generally be higher than total load on the system. So total load on the system will generally be higher during the daytime and evening, and lower during early morning and late evenings. So like that, it will be scheduled according to the time sequences. That means total load on the system is higher during the daytime. So load consumption is more in the day session, and in the early evening, and lower during the early morning. In the early morning, the production, whatever the load consumption, that will be more. And it is not economical to run all the units available at that time. We cannot run all the units at a time. So the commitment of a generating unit is very difficult to decide. Why? Because all the time sequences, time lapses cannot match. In the morning sessions, utilization of the load is more, load consumption, and in the early morning, the load demand is very less. So like that, there will be some variations. So these variations may interlink to the unit commitment problem. So cost of the system can be saved by turning off the generators when they are not needed. Means if the load is thrown off, loads are not consuming the power, means you need to shut down the generators. So you need to shut down the generators. That means you are saving the energy. So this will impact on the total economy of the system. Some things that are considered when determining the best schedules, those are operational constraints. What are these operational constraints means? Solution must respect many operational constraints. Like with unit types, what are the number of units? There are different types of energy production units such as thermal, nuclear, tidal, and renewable energy sources. Most of the cases we are utilizing thermal energy. The first preference is thermal. Why? Because there is no difficulty here like seasonal effects, etc. So based on the availability of the coal, the power generation will be takes place. If you go with the idle case, this is the second place. This only runs on the availability and storage of the water. Availability and storage of the water. Storage of the water. So this will goes to second preference. Even though the running cost, whatever it may be, the investment for this is minimal compared to thermal, But if you compare with the availability of the source availability is continuous in thermal. So most of the plants, they are interconnected to thermal power plants. Most of the loads, they interconnected to the thermal power plants. Meanwhile, they are interchanging their exposures to the hydel case. So like these, thermal and hydel will play a key role in the power system network. Remaining availability of the nuclear particles and the renewable energy sources, these are going another preferences. Here the cost of generation, running cost, etc. will be more for nuclear. So nuclear power plant operating with more cost. Whatever it may be, operating and running costs, which are more for nuclear case. Coming to renewable energy sources, installation cost is high and running cost is very less for renewable energy sources. But these also depends upon the atmospheric conditions like solar, wind, etc. And the installation is more, but maintenance and running cost is very less. So based on that, renewable energy sources are designed. Next, monopolistic operator or transmission system operator will include one of the operational constraint. That means whether the units and grid are managed by a monopolistic operator or transmission system operator, that we need to check into the system. Next, coming to the unit commitment, which refers to the optimization model, which is used in the power industry for scheduling and dispatching electric power generation. Like especially in the presence of uncertainty parameters and real-time uncertainty, these are used. So in power system networks, the demand may varies and it will be associated with human activities. We cannot say that this is fixed load demand. We cannot say that this is fixed load demand. So we will not define fixed load demand. And the demand also affected more. That means load is always light during the night hours. Night hours, the load is very light and it starts increasing right from the morning. Usually reduce its peaks level in coming to the evening. That means slowly the curve increases. It goes on slowly increases and it will be peak during the daytime and it will be false when it comes to the midnight. Like that it will be happens. And the peak level reaching in the evening and again it falls during the late evening periods. So demand is also affected during the weekends as well as by the weather conditions. Hence, many methods have been developed for load forecasting. So many methods are introduced for making load forecasting techniques. The methods for making load forecasting can predict the load for a particular period varying from small as few seconds to days. That means based on these load forecasts, the usual practice is to prepare a commitment schedule. So that is for startup and shutdown of units. We should have certain procedures to make exciting the generators and to shut down or to off the generators. So based on that, we can schedule the generators. So the commission of a generating unit means to bring it to speed, synchronize into the system, and then connect it to the where the power can be delivered to the load reliably. So in the early stages, the main criteria of unit commitment were efficiency of number of units. That means units used to be ordered as per their respective efficiencies. So based on the efficiency of the particular generator, generator 1, generator 2, so on up to n number of generators, their efficiencies are concluded. This will give the resultant values. So based on the peakest efficiencies of the generators, they will be scheduled and they will be tied to the load component. So the most efficient unit used to be committed first and then the next unit if necessary to meet the load demand. So from it will be prepared PRT list used to be committed. So soon it was realized that optimum unit commitment may be obtained using input-output characteristics. So we should take the characteristics. Based on that, the UC problem will be follows, and it will be termed as cost curves. So cost curves will be followed by one of the unit commitment case. And today all commitment techniques are based on these cost curves. So here classically unit commitment is the determination of optimal schedule and the generation level of each unit over a specific time horizon. So time horizon may be in hours or in weeks like that. So time schedule will be prepared. Next. So Baldwin, one of the scientists, he was first to report the study of economic shutdown of generating units. He introduced one of the methodology called by the name Baldwin, and since then many optimization techniques came. They have been used to obtain the solution of unit commitment problem prominently. Among these are dynamic programming, branch and bound, and Lagrangian relaxation. So these methods will give suitable solutions to these unit commitment problems. How generator should schedule, how generator should start and shut down during the peak load and non-load conditions. So these are decided by one of these programming methods, branch and bound, and Lagrangian relaxation methods. What is a statement of unit commitment problem? How to define the unit commitment problem means the unit commitment problem in electrical power production is a large family of mathematical optimization problems where the production of set of electrical generators are coordinated in order to achieve some common targets. So usually either match the energy demand at minimum cost or maximum revenues from the energy production. So total load of the power system is not constant, varies throughout the day and reaches a different peak value from one day to another. So it follows a particularly hourly load cycle over a entire day. So there will be different discrete load levels at each period, which will be happens at different intervals. So due to all these reasons, whatever we stated now, it is not advisable to run all the available units at all the time. The load on the generators may increases. In some cases, the load may the generator may malfunctions and it may be disconnected to the load or grid. And it is necessary to decide in advance which generators are to be started up and when to connect them to the network and the sequence in which operating unit should be shut down and for how long it will be continuous. All these procedural means we should frame according to that. So when to start the generator, when to shut down this generator, the sequence of scheduling must follows for the power system network for suitable unit commitment case. So the computational procedures are derived for making such decisions are called unit commitment. All these procedures which are designed for this framing rules and regulations of the generator schedulings are decided with unit commitment problem. And when the schedule is supposed to be takes place, the connection of the system is said to be committed. And the problem of unit commitment is to determine the units that should operate for a particular given load. So the commitment of a generating unit is to turn it on or to bring it up to the required level of speed. So this will make the synchronization of the generators that will increases the efficiency of the system and it will be connected to the load so that it can deliver maximum power to the network very easily. So what is the need for unit commitment problem? Why should we go for unit commitment problem means the plant commitment and unit ordering schedules, they may extend the period of optimization from few minutes to several hours. Some minutes time to several hours. So weekly pattern can be developed from daily schedules, likewise monthly, seasonally, annually they will be scheduled, and they can be prepared by taking into consideration the repetitive nature of the load demand and the seasonal variations are going to be takes place in the unit commitment need. So a great deal of the money can be saved by turning off the units when they are not needed for the time required. So if the operation of the system is to be optimized, the unit commitment schedules are required for economically committing the units in the plant to the service with the time at which individual unit should be taken out from the return to the service case. So that's why unit commitment is scheduled according to the generator functionalities. Whatever the number of generators they are going to be. So this is the problem is of importance for scheduling the thermal units in a thermal plant. So as for other types of generation such as hydro, they aggregate their costs such as startup costs, operating fuel costs and shutdown costs. They are negligible so that they will be shut down as per the requirement of the generator cases. So it is very much important to the all the generators they should schedule according to the case. So enough number of units will be committed to supply the system load to reduce the loss or fuel cost. So by running the most economic unit, the load can be supplied by that unit operating cost closer to the better efficiencies. So here so many difficulties to find the unit commitment solution. That is a time consuming process. If the number of units are more, number of combinations will be more, then the complexity of the entire bus system will be increases. So due to which n number of units, the n number of combinations will be 2n minus 1. The n number of combinations becomes 2n minus 1 cases it will be executed. So the various constraints existing in unit commitment problem. What are the constraints in unit commitment means? There are so many constraints to be considered in solving the unit commitment. One is a spinning reserve. So what is spinning reserve means? It is the term used to describe the total amount of generation available from all the synchronized units on the system minus the present load and the losses being supplied. So how can we calculate the spinning reserve complexity means? This will describe the total amount of the generation from all the synchronized units on the system minus whatever the present load and losses being supplied. So here the synchronized units on the system may be named as units spinning on the given system. So the spinning reserve is better analyzed by one of the formula, that is total generation output of all synchronized units at a particular time minus present load plus losses at that given time. So likewise spinning reserve is designed. Next, coming to static reserve, to meet the load demand under contingency of failure of a generator, its derating caused by the minor defect. So it is made so that total installed capacity of generating station greater the yearly peak load by certain marginal cases. So this is called static reserve. So thermal unit constraints are these are the constraints which requires crew to operate them, especially where turned on or off. So a thermal unit may undergo only gradual temperature changes. So that is translate into the increased number of hours that should require to bring it into the online case. So therefore various constraints that arises as single case that will gives the thermal unit commitment constraints. Next case is minimum uptime. What is minimum uptime means? Once the unit is running, it should not be turned off immediately. So we should take the scheduling of the generators with minimum uptime. Once if it is running, it should not be turned again. So we should take some more time. That is called minimum uptime. Similarly, minimum downtime. Once the unit is decommitted, there is a minimum time before it can be recommitted. That will be treated as minimum downtime. Next, crew constraints. What are crew constraints means? If a plant consists of two or more units, more than two number of units, they cannot be turned on at the same time, since there are not enough staff to attend all the units at a time. So this is the reason we should go with the crew constraints. That means a group of constraints. Next constraint is startup cost. What is startup cost means? This is incurred when the generator is put into the operation. Cost is dependent on how long the unit has been inactive. That means while the startup cost function is non-linear, it can be discretized into hourly periods. That means giving a stepwise function, the startup cost may vary from maximum, and it will be say that cold start value to a very small value if the unit was only turned off recently and it is still relatively close to the operating temperature. So, two approaches to treating a thermal unit during its downtime case. That is, first approach is cooling, that allows the unit's boiler to cool down and then heat back to the operating temperature in time for a scheduling case. That will be turned on in the scheduling time aspect. The second approach is requires that sufficient energy be the input to the boiler to just maintaining their temperature coefficients. The other constraints present in the unit commitment are, in addition to the system and unit constraints, those are needed to be considered in the UC division to make the decision. Here they are described as fuel constraints. What are fuel constraints means? Due to the contracts with the fuel suppliers, they may not able to supply within the given period. So some power plants may have limited fuel. So or it may need to burn a specified amount of fuel given a particular period of time. So a system in which some units have limited fuel or else have constraints that requires them to burn a specified amount of fuel in a given time presents a most challenging unit commitment problem. So here main problem is the fuel case. When fuel availability is not continuous, then unit commitment scheduling cannot be possible in the given period. Next, so here we should consider with must-run units. So some units are given must-run status during the certain times of the year for reason of voltage support onto the transmission network or for such purposes as supply of steam for uses outside the steam plant itself. So they must run the units including the units in forward contracts. So the units may be exercised or called for put options. They may treat with RMR units, nuclear power plants, some congestion units and units with renewable sources like wind turbine units and some hydel power plants. So these will must run units they must consider. And a must off units are some units they required to be offline due to the maintenance schedule of forced outage. So these units can be excluded from the UC decisions. So these are treated as must off units. And emission constraints are there are some emission like sulfur dioxide, SO2, nitrogen oxides, NOx, carbon dioxide, CO2, and mercury which are produced by fossil fueled thermal power plants. The amount of emission depends on various factors. So such as the type of fuel used, level of generation of the output and the efficiency of the unit. So based on these constraints, these are considered with the emissions. So here production cost should be minimized by compromising in order to have the generation schedules. That means which will ready to meet the emission of the constraints. So here one of the solution methodologies for unit commitment are designed as which will be involved with the problems which are very difficult to solve, and for that consideration one is loading pattern for the M periods which will be using load curve and which must be established. Number of units should be committed and dispatched to meet requirement of the load. So the load period and the number of units should supply to the individual loads, and it may be combinational of the any loads which will be considered cumulative. So there may many classical approaches which should be introduced, and also it will be developed successfully for some of the approaches. They are enumeration techniques, or brute force techniques, priority list methods, dynamic programming methods, Lagrange relaxation, integer and mixed integer programming methods, Benders and decomposition methods, branch and bound methods. So these are one of the suitable methods for given unit commitment problems. And other non-classical methods are genetic algorithms, greedy random adaptive search procedure, particle swarm optimization, simulated annealing procedures. So these are used one of the other methods. So whatever it may be, the objectives of this unit commitment problem is to optimize the electricity generation to cover the forecasted demand in accordance with the fluctuating price and the constraints on reservoir capacity of the different units. So the known characteristics of the generator are usually minimum and maximum capacity. So that means ramp up and down the capacity, how much more or less the generator they can produce from one period to the next, and availability, fixed cost of the operating generator, variable cost of the producing one unit for the electricity, and predictive models that are used to generate the forecast of the thermal scheduling process, like that. So likewise, we can utilize the unit commitment problem more with these thermal scheduling process according to the generators. They will be connected to the power system network. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.